Hello everyone, this is demonstration phase of the RC Walker IS example code. IS stands for Independent Servo Control, essentially independent servo control during motion play. So we use a single mini, Zero, a Python. So we'll be using Pygame to do some graphics and to capture some of the keyboard pushes. So we have Pygame also used. So just a reminder again, I'm using the Smart Avoider motion group in this example code. All the motion pages, a run motion method. I'm using, you can see the motion number 61 and all that. By default, the second parameter weight equal true. So by default, any command that you tell it to run a motion page, the Python interpreter will stop there and wait until this motion 6 is finished before it goes on to the next statement in Python. But Edbot gave you an option where you put the second paragraph weight, you set it to false, and then it will send the command to run the motion page 6, and it goes on and execute the next Python statement, whatever that happened to be inside your program. So I'm using weight equal false here in this example. When it's by default, you don't see this second parameter at all. It means that weight going to be by default is true. That means it will wait until a certain motion page is completely finished before it goes on and execute the next Python statement. So this is important. So essentially, I'm trying to run the motion as fast as I can through Edbot tool in this particular example here. So if you remember, when a motion unit or unit page is played, of course all the 17 positions that you define in your unit in your motion page is going to be executed and applied. So but for example 17 and 1 are included in those data for motion unit or pages, but sometimes I may want to move the arm independently of whatever motion the robot is doing, or I want to scan the head independently of what the motion of the rest of the body is doing. Okay, so in order to do that, you have to basically, I want to isolate, for example, Servo 1 and Servo 17 for motion play effect. What you do, you set the joint offset to 1024. More explanation in the book. And if you remember from task programming, they have function that are designed for you already. So here I'm setting the joint offset of Servo 1 to 1024. Therefore, when I'm playing motion index number 9, ID1 essentially is not affected by your motion page number 9. So therefore, I can set it goal position to anything I want, independently of what's going on in the motion page number 9. Alright, so how do we do that in Python? So in Python, for example, to raise the arm, essentially I want to move servo number 1 essentially. So I'm using set custom method, specifying your robot. For servo 1 joint offset, it happened to be address 232. 2 means I'm sending a message that is 2 bytes long, and that message value is 1024. When you send that, you can have any motion page you done. You can just control the servo 1 directly yourself using the method set servo position. Okay, so that's the key. I'm also using Pygame. I'm using Pygame for graphics display, a little graphics display, and then some to use that to capture key pushes from the keyboard. So you see Pygame, I use that to load a little background pictures. I use it to get some caption here and some other text here, and I also use it to capture which key being pushed down, like up, down, right, left arrow here, or I can use also the space bar or the key for 1, 3, or 2, or 4 on top of the keyboard. Agent parallel or sequential if, some people call that sequential if, to capture all the key pushes as fast as I can. And once those key what I captured, and then I use that to assign correct value or specific value to parameter robot mode. And then I use robot mode in regular if-else structure to actually trigger the different motion I want the robot to do. Forward, backward, right, left, that sort of thing. Or raise the arm, or lower the arm, scan the head, or stop scanning the head. And you remember all the method used to actually move the robot as you with the weight state equal fall. So we'll try to push it through, stress the Edbot servo tool as much as we can to see how does it well that work. So remember again at runtime, remember I had to make sure that zero connected, and you can hear like it connected well, run away. And then at runtime, when you run it, it had a little menu to show that, hey, use the arrow key to move the robot. You can tap 1 to raise the left arm, 3 to lower the form to normal, 2 to start scanning the head, 4 to stop scanning the head. Okay? So if you give me a few minutes, I'm going to pause the video now, get set up Python and cameras and stuff. Okay, so here we are back. Zero connected, okay. And let's try it.
Connected to robot Zira. Zira is ready for a command.
Okay. Out of the way, single control. So tap 1. Interesting. What's happening here? Here we go. 1. Oh, it's taking really hard time to load norm. Over itself. I want 3 to load the arm. Okay, load the arm. See, I'm gonna go forward and raise the arm at the same time. You have to kind of pump 1 3 1 3. You can see it stack up the command. It's probably easier if I turn around and around and around while doing things. Unfortunately, for whatever reason, connection to zero is closed. So we're gonna pause it and try to re-establish connection. Okay, I succeeded in reconnecting zero. I need to stop this one and restart all over.
Connected to robot Zira. Zira is ready for a command.
Okay. Very good. Okay, very good. Out of the way to bring it in. It's normal. Pushing 3. I'm gonna go backward. Keep on turning left and see if I can scan the head. So I'm bumping around. Let's go back here. So I'm gonna keep it up. So stack up quite a bit of key to the scan. It looks like it's stacked up the different key, the flow, the different key pushes that I do. So I stop pushing now, but you see all the backward push I have done. Now finally I do lots of right key. So interesting. So I did in practice. Oh, here we go again. Something happened. Edbot doesn't like me. No, doesn't like Zira. It closed connection again here.